All right, Unit 4, quiz to preview, getting us ready for that quiz that's coming tomorrow. Okay, first right off the top here, identify the transformations. Remember, that's just a fancy name for shifts, but this is the way it's going to be written on the quiz tomorrow. From the original, y equals log of x for the following graph. In other words, going from this to this, what are my two shifts? So remember, inside my parentheses, which directions are those normally? Left and right. So, but again, it's the opposite of what we think because that value is x minus h, or the opposite of h. So, we're heading left 1, which means this is my up or down, which means it's going to go down. So we're down 7. Okay? That's all we're doing on that. Rewrite the following in either a logarithmic or an exponential function. Nice thing, I have things to look at on each that are similar to what I'm supposed to be doing for the other. This is supposed to look like this at the end. So I can kind of look back and forth and go, okay. So base, I always know that's base. Okay, base. How does that work? Oh yeah, my exponent's always here and my answer's always here. Now again, we're just rewriting. 5 to some power equals 25. You're not solving it. Don't just write x equals 2. Rewrite, okay, not evaluate. And then again, the other one, since it's already an exponential, is going to go into logarithmic. But I've got this one to use as my example. So I can say, okay, log, we know my base is always here. So then again, my exponent is always on the other side of the equals. Okay, and luckily we don't have to figure that out. 8 to some power of y equals 5. Just rewriting. Okay, but that's what we're doing here. We've got to understand where my base, where my exponent, where my solution is, to be able to work back and forth with those. Okay, evaluate the following. We've talked about a couple of different ways that you can do this. One of my ways is saying, what do I take this number to what power to get this one? Now I'm hoping you realize that taking a certain number or even variable term to this particular value always gets me 1, which would be 0. But if you forget, okay, we've talked before about sometimes you go to take a quiz, you have a brain cramp. If you do that, you can use change of base, which again is the log of the of value, my physically larger number, divided by the log of my base. Okay, and I can get the answer that way too. So either one works. But again, we've talked about how it's preferable to do it this way because when we get to solving soon, we're going to have to be able to do some of these things. So 6 to some power is 216. Now again, may you not know that off the top of your head? Maybe, but let's play a little bit. You're like, I don't know, squared is 36. That's not big enough. Oh, okay. 3. We've talked a lot about the ones in number 6. Okay, 6 to what power gets me to 1 over 36? And we always say, okay, first things first. 6 to what power gets me to 36? 2. Okay, now how do I get it to where it flips going from the numerator down to the denominator? That's right, hopefully somebody said it at this point. You use a negative exponent. And I could even punch that into my calculator, 6 to the negative 2, and then take the decimal and hit math, enter, enter, and I can kind of play with it. But again, it's not that bad. Just go ahead and kind of work it a little bit. Make your brain work a little bit. 7 to the x equals 49. 7 to what power is 49? Better not need the calculator on that one. Okay, 2. When we find the inverses, okay, remember, inverses, switch x and y. And then we're solving for y. How do I get rid of the log base 10? And don't say divide by log of 10. Okay? What's that big word we were talking about sounding all fancy when we were doing it? Yeah, we got to exponentiate. Okay, because again, the 10 and the log of its same base are inverses. So that helps me to get that out of there. And the only other thing I got to be careful of is we exponentiated. This became an exponent. It's 10 to the x power, not just 10x. Okay, little details, little details. Okay, expand the expression. Now we've talked enough about this and written it out on your notes and another review we did and all these places. I'm not writing it out this time. So we just got to think about this. We're always starting with our multiplication and division. Well, I don't see any division. I don't see any fractions. So this is all multiplication. So I need every place that I'd be able to put a multiplication dot, I need to replace that with a plus sign. And yes, you have to write log every time because they're becoming separate terms. And then the only thing left, once I separate them there, multiply becomes add. So if I have any exponents, they'll come down and become coefficients. Okay, but only on the term where the exponent's at. And I'm set. Okay. Same type of idea working on number 10. Notice there are not any exponents outside the parentheses, so I don't have to play that game. So I get right in here and you're like, well, there's multiply and divide this time. Does it matter which one I do first? And it really doesn't. Okay, so if you see the divide and you're like, yeah, I don't like that, let's get rid of that first. Okay, so I could do log of ab to the 5th minus the log of x to the 4th. If I wanted to do the divide first, if I wanted to do the multiply, I could. But then there's just a couple of things going on still. And again, push away that temptation to try and do everything at once. Let's just take care of the multiply next. So log of a plus log of b to the 5th. And I'm just leaving this alone for now. Because again, if you do one step at a time, you're less likely to make an error. Now that I'm rid of my multiplication and I'm rid of my division, now I can take that last step and get those exponents taken care of. They become back into coefficients, and I've got it. But again, I got to know the rules. I got to know that multiply becomes add, that divide becomes subtract, that exponents become coefficients. If I don't, that makes this kind of difficult. Especially when I got to go back now and do it just the opposite direction for numbers 11 and 12. Condense, turn them into a single logarithm. And we said all the steps get done backwards. Now, the coefficient has to get done first. Don't take the minus with. So the natural log of a minus the natural log of b to the 5th. Don't see any multiplication, but I don't see any addition, but I do see subtraction. So subtraction, when we go backwards, turns back into division or a fraction. One logarithm. Don't write ln a over ln b5. One expression. And then I do it one more time here on 12. Again, coefficients become exponents. I work that through. Okay, so coefficients to exponents first. Then again, take it in any order you'd like on the rest. I'm just going to work left to right. So I'm going to deal with this. The plus becomes times. So I've got log of x to the 4th y squared. Again, if you want to try and take them all on at once, be my guest, but be careful when you do, because the minus will become divide or a fraction. And again, this is a single logarithm. One fraction, one product, whatever it happens to be when we get to the end. Okay, now we go into review back for a little bit. It's not out of this unit, but it's back from like quiz 1 type stuff with our growth and decay. We got to be able to keep this straight. So in looking at the function f of x equals 3 times 5 fourths to the negative x, is it a growth or decay? Be careful. I look at this, and normally that's my b value. That's what determines growth or decay. So normally I'd look at that and I'd say 5 over 4, well, that's bigger than 1, so it's growth. But make sure to pay special attention to your exponent. It's negative x. So now that 5/4 to the negative x is going to act like it's reciprocal. So if it's 4/5 in there for b now, is that going to be growth or decay? Right, it's going to be decay. Now you can't, as an answer, just say negative exponent. We talked about that before. Because here, you know, if I had this and I had a negative exponent, it wouldn't be decay, it'd become growth. So either you show me what happens or what it acts like, or you can say the negative exponent makes the b value act as its reciprocal. Well, I didn't even come close to spelling that right. Reciprocal. That's better. Okay? Verbally is fine. This way is fine. Just say negative exponent or because that's what it looks like on the calculator. That doesn't, okay? That's not a good enough justification because somebody even without a calculator should be able to answer that. All right. So moving on here, the last question on this side. If f of x is 5 to the x and g of x is 5 to the x plus 4 plus 3, explain how to obtain g of x from f of x. What are the transformations? What are the shifts? Really, I only have to look at this one. What is that plus 4 and that plus 3? What do those two shifts signify? Left 4, because that's my left-right shift, just like when the log, it's in the parentheses. And that's my up or down shift, the one on the end that's not stuck somewhere else. Not too bad so far, right? So we head to the back. Okay, graph the functions. I warned this was coming. We're going to have one that's growth and decay, okay, and one that's a logarithm. So again, it's going to be your pick on how you deal with some of this stuff. I know some of you well enough to know a lot of you are going to go straight to the calculator on this, but we're going to kind of re-stress a few things as we do it this way. So hopefully to be able to save you some time. Now first, that plus 2 is not in the exponent, so I don't want it in the parentheses with my x. Okay, I'll look at my graph. I notice it's shifted upward 2. Okay, so before I ever start, reminder, when it's growth and decay, my domain is always negative infinity to infinity. Okay, my range moves if there's an up or a down shift, because normally it's at 0 to infinity. But I had an upward shift this time. So my range moves with it. Okay. And we talked before about with these that we're just basically going to look for our whole number values. We do want to be accurate with as many points as we can. But I've got to make sure, and we didn't do this as much before, but I think you're seeing the benefit of it now. Okay, there's actually a horizontal asymptote with these. No, you don't have to label it. But I always tell you, I'm going to watch like a hawk. And if your graph goes below that value, since it's shifted up to, I'm going to mark parts of it wrong. Be careful. I'm warning. Okay. And then my end behavior with this, remember there's always a connection. Okay. My domain goes with the x's in this. So when we're doing growth and decay, one's positive, one's negative infinity. And my range values always go with my f of x's because it just stands for y. It's fancy function notation. So which one's which though? as x is going to the left towards negative infinity, am I heading towards a y value of 2 or positive infinity? Well, since I'm heading up, looks like I'm heading towards positive infinity, which means then as x goes to the right, what y value do I approach? I approach 2. Just make those connections and use the pictures. Okay, not a bad deal. Now when we do it for our logarithm, remember there's some things we found that were easier. First of all, what's my shift on my logarithm? Right 5, because inside the parentheses is left or right, and it's the opposite of what we would think. So when I do this, can you remember our 2 base points that we use to graph logarithms? Don't freak out if you can't. We're going to look at the calculator too. Okay, 1, 0, and 10, 1. So what's that do for me? Well, if I know those, all I got to do is go 1, 2, 3, right 5. Now 10, 1's a little more interesting, but we'll make it work. 1, 2, 3, 5. And I know, again, it's not asked for. What's my vertical asymptote going to be on this? Hopefully somebody at this point has said 5, because it starts at 0, but we had our right shift. You're like, ooh. So it's kind of just the opposite of the other one, because with growth and decay, it was up and down changed it. Now it's right and left, and that's true. We talked about how there's some similarities with these before. So I get that in there because then when I draw my picture again, I'm not being silly and going past where my border is going to be at. Okay, get our arrows, make sure we got it going both ways. So now we're back to domain and range. But again, we talked about how they're inverses. Over here, my domain was negative infinity to infinity. It went forever left and right. Now over here, it goes forever down and slowly up. So my range is the one that's negative infinity to infinity. And it's my domain that normally starts at 0, but it moved 5 along with my vertical asymptote. And you're like, oh, x-intercept is back. Do I have to do the big mathematical thing? Well, let's find out. Let's get this typed in. Okay, again, make sure you get it in the parentheses. Bring up my chart. Okay, there's all my error. Oh, I got fortunate. Because remember, my x-intercept occurs when y equals 0. So if I can go to my chart, and there's y is 0, I would just as soon do it that way. You're like, well, what if it's not? Then we would have to, again, exponentiate and start working that out. Okay, but I'm just I'm giving you a heads up. You're not going to have to do that tomorrow. Okay, so that gets us situated with the first of our kind of review type items here with our growth and decay and our log graphs. So then we move down a little. Oh, application problems. Where have you been? Well, you're back. Okay. Scientist estimates that a specimen begins with 450 bacteria. Now notice here before we ever start, I'm giving you the expression or the equation to use. Don't make up your own. Okay, now we got that out of the way. A scientist estimates that a specimen begins with 450 bacteria. Okay, that's my starting value. That's my A. If this specimen grows by 15%, that's my rate, but I need it into a decimal form. Now, most of you, I think, at this point know that it'd be 0.15, but if you don't, reminder, take any whole number, divide it by 100, becomes your decimal value, 0.15, okay? So, 15% every minute, write an equation that represents the bacteria's growth. Growth plus decay, I'd use the minus, don't use both. How many minutes will pass before the population reaches 1,000? Okay, first things first. .450 bacteria. 1 plus my rate. I don't know the time. That's what I'm looking for, okay? So, when will the population reach 1,000? We've talked before about some ways this could be done. Okay. We could do it algebraically, but when we've got the calculators, and in class we do, we're trying to find the spot once y gets to be greater than 1,000. So, we're going to take our expression, put it in here, look at our chart, and once we find that time period where the 1,000 would occur, so in between 5 and 6, okay, 5 to 6 minutes. And if you want to play the rounding game and round up and just put 6, you could. But that's what we're looking for, okay? Second one. Oh boy. We've been down this road before too. You have to decide between two job offers. Judison Industries offers you a base salary of $30,000 with an $800 annual raise. Okay, got the equation here already. Warren Corporation has offered you a base salary of $25,000 with a 4% annual raise. Okay, already have the equation. If Jedison's offer can be modeled by this and Warren's offer is modeled by this, which offer is best? Explain your reasoning. Okay, this is the best way, hands down, to do this. You don't know, looking at 1 year, which one is the best offer. You might not even know in 2 or 3 years. You're looking at this long term. So we're going to type both of these into the y equals part of the calculator at the same time. Be careful to make sure you're typing in everything exactly. Ooh, just as I say that, exactly the way that it is in the problem. So when I go to look at the chart, okay, you notice here's my first year. At Judison it'd be 30. Okay, Y2 is Warren. This is Judison. Now when you're at a job most of the time, okay, it asks me how many years later will the salary from Warren exceed? How long is it going to take till the Y2 column is bigger? That's what we're asking here. So let's look for that first. So I start to scroll down. Nope. Oh, we're getting close though. Oh, we're close. Okay, there. We finally jumped it. How many years later? It's going to take 12 years before the Warren Corporation salary exceeds. So, with that in mind, let's kind of backtrack now. Which offer is best? You actually could give me either one as an answer based on some information. So, what could you say? You could say, which offer is best? You could say Judison, because I probably won't be there over 10 years, or I want money more now. I mean, the average person stays at a job somewhere between like 6 and 7 years. So, I mean, that's a legitimate thing to say, you know. I'm making more money at Judison the first 10 years. Why would I want to be at the other place? Or you could say Warren, because if it's my only job, maybe you're a loyal person. Maybe you think you're going to get that first regular paying job and be there for 30, 35 years. I will make more later, because once you hit year 12, for the next 20 years, you're going to be making more at Warren Corporation. It's a smart thing. But you can't just say, Judison, because it starts bigger. No, you've got to give me a little more than that, okay? And the question will be kind of similar to this. I'm not going to throw a spin on you, so just something to ponder. All right, last one. Suppose we invest our birthday money into an account paying 6.5% interest compounded monthly. Use your calculator's function to determine how long it will take for your money to triple. How much money did I start with? Yeah, they didn't give me a number. So I get to make one up. Now, normally when we do this, I'll start with 100 or 1,000, something nice and easy to work with. So I'm just going to start with 1,000. So my p-value that I'm going to use, for my case, is going to be 1,000. You can make yours anything you want. 1 plus, my rate is a decimal, be careful. Don't put 0.65, that'd be 65%. That'd be awesome. I'd like to, if you work at a bank and you do that sometime, let me know. I'd like to come put my money there. So 0.065 would be my rate over my n value. Now remember, n value is how often does this occur in a year? It's compounded monthly. How often does monthly happen in a year? 12. So that's my n value there. And then I notice up in the exponent, it's n times t. But I don't know how long. That's what I'm trying to figure out. How long is this going to take? Well, how long is it going to take to do what? How long is it going to take for my money to triple? Now again, this depends on what you started with for your initial value. I started with 1,000. How much is triple that? Okay. That's what I want to get at the end. So here's how this works and how I can figure out the answer to the other part. I'm going to plug this that I've got outlined in purple into my y equals. So I need to clear this other stuff out. And as I work my way through this, and I don't have a t to work with, so I'll just work with x. Make sure that you did all the little things, like make sure your decimal's in the right place, that you put the caret in, stuff like that. And so now what I'm going to do is I need to see, when does y get bigger than 3,000? So I start scrolling down, scrolling. Okay, when that hits 3,000, again, you can put approximately which year. If you're really close to one of the years, you can do that. So like here, I'm really close. It's going to take about 17 years. So that's what I'd write. If you wrote 16 to 17 years, you know, I'd accept that too. Okay, you have basically the quiz in your hands. With answers, you have a video, you have a key to look at. If you need to grab an extra to look at going into the quiz tomorrow to practice, that's good. If all you did was stare at me this entire time and write down what I said and you do nothing else, this is going to go bad. Do your homework, get your practice, put the time in, it will go well and you will be happy for it. But if you need me for any other questions, see me about it. See you tomorrow.